Let's again discuss what is the property of self-induction. Self-induction is the property of a coil or a conductor by which it opposes the change in the current in itself. So if there is a change in the current in itself, then what will happen? This coil will try to oppose that change always. Yeah? So if this was a coil, there was a current, and this coil had certain number of turns, area of cross section. Due to this current, this coil will be producing certain magnetic field. Due to that magnetic field, there will be certain magnetic flux associated with the coil, and if this current I is changing, this flux is also this flux will also change, right? Yes or no? So basically, the this flux, when it will change, this change in flux will try to induce certain current, right? The change in flux will induce certain current or certain EMF, right? Certain EMF or certain. Yes or no? This phenomena is basically called as what? Self-induction. Is this clear, guys? What is self-induction? So always remember, self-induction is a phenomena due to which okay. So that is why, since this is the source and this is the cause, and there only the effect is there. So that's why it's self-induction. Okay. Is this clear, guys? Please remember, note, self-induction is a phenomena in which a current is induced in the same coil, which is producing the magnetic flux, right? Is this clear? Or यहाँ पे you can write due to change in its own current. Always remember this particular thing, the flux associated with this thing, will it be directly proportional to the current? More the current will be flowing, more will be the magnetic field, and more will be the flux associated, right? So that is why phi m will be directly proportional to I, and when you will remove the sign of proportionality, you will introduce a constant. That constant is L, and L is called as the coefficient of self-induction. Okay, L is called as the coefficient of self-inductance. I'll explain. This is a scalar quantity. This is having SI unit. Can you see over here? This is Weber and this is ampere. So if someone asks you what is L, the unit for L, it is Weber per, or this is termed as Henry. Can you see Weber per ampere is basically 1 Henry. But generally 1 Henry is a bigger unit, so we use smaller units, right? We use millihenry. Okay. Try to find out the dimensional formula of this. Well, that's the homework for you people. Guys, whenever you're done, just tell me. So always remember this, guys. Hello. Always remember this. The current which gets induced, the current which gets induced in the coil is in accordance with, always remember its direction and everything is in accordance with Lenz's law. So don't think like it's a Lenz law will not be applicable over here. Lenz's law will still be applicable. Okay. And since always it is opposing, so this property is also known as, the property of self-inductance is also known as the inertia. Do you remember inertia from 11th grade? Hello. Hello guys. Hello people, can you hear me? चलो ठीक है. So this property is basically called as what? Self-inductance. Is this clear, guys? Is this clear?
Yes, sir.
So please remember, generally people they get a little confused in this thing. If inductor is also opposing the change in the current, can you see inductance is basically opposing the change in its own current, right? Yes or no, guys? So is there any difference between an inductor and a resistor? Please remember, inductance and resistance are both the properties of a conductor. They both are the properties of the same conductor only. Please remember, resistance opposes the flow of current. Resistance, it opposes the flow of current, whereas inductance opposes the change in the Please remember, inductor will never oppose the change. Inductor will never oppose the flow. Inductor will only oppose a Inductance will only oppose the change in the flowing current. Whatever current is flowing, it will try to oppose the change in that current. If it is increasing, then it will try to decrease it, and if it is decreasing, then it will try to increase it, just like that. Okay. Also, pure inductor is a hypothetical concept. Understand what an inductor is, right? Just like resistance for those conductors which are showing the properties of resistance, we named them as resistor, right? So similarly, those conductors which will show the property of inductance will be termed as inductor. Pure inductor is a hypothetical concept, because always there will be certain resistance associated with a conductor. Check. Whenever you're done writing, just tell me. We'll continue. Are you done?
Yes, sir.
Please write down next heading. Self-inductance of a solenoid. This is very important as per your school point of view as well. So we'll write the derivation. So let us consider a long solenoid of length, let's say L, and radius small r. And please remember, whenever I am telling you it's a long solenoid, always means that the length of the solenoid is way bigger as compared to the resistance, as compared to the radius, right? And also, the solenoid has how many turns? Solenoid has, let's say, capital N turns in total. Do you remember the turn density? If you remember turn density from the third MEC chapter, small n, in number of turns per unit length, right? So turn density is small
Yes.
n, which is equals to n by n. We can define this as well. Okay. And now, sir, we want to find out what is the inductance. What is the inductance of a self-inductance of the solenoid? To find is basically what is the self-inductance of a solenoid. if the current flowing in the solenoid is I. Okay. So we need to find out self-inductance. Basically, we want to find out what is the value of L. Sorry. Now, suppose, guys, if I have a solenoid, very long solenoid, है ना? So if I say if the current flowing in it is basically I, then how much magnetic field will it be producing? Does anyone knows what is the formula for magnetic field inside a current carrying solenoid? You remember magnetic field was B, which was equals to mu naught into small n into I, right? Everyone remembers this?
Yes, sir.
So can it be written as mu naught n upon capital L small l into I? Can I write it like this? Magnetic field is basically this. If this is the magnetic field and if the area of cross section is A, and we know area is basically because we need to define in terms of R, right? Yes or no? If let's say area is A only, let's define in terms of A only. So if area is A, then can I say the flux associated with it? You will write it in statement. If the current flowing is I, then the magnetic field produced by coil is basically this much. After this, then the magnetic flux associated with the coil due to the magnetic field. Please read this statement twice, है ना? Produced by its own current, that will be equals to n into b into a. I'm avoiding that cos theta because we know area vector and magnetic field vector are in the same direction in this case. So nba, yes. So this will be n, b will be equals to mu naught into n upon l into I into a. Yes or no? Can I write it like this? nba. Then I can solve it a little bit and I can write mu naught n square a inside L here, and I'll write I over here outside and phi m is over here. Yes? Yes or no, guys? Can I write it like this? And but we know by the definition of self-inductance. What if phi m equals to phi m is equals to L multiplied by I? So can you see over here by comparison? So by comparing, this is one of your school's derivations, so please pay a little bit attention over here. A naught n square. This is the okay. Is this clear, guys? This is the coefficient of self-inductance for a ideal solenoid. Always remember. Coefficient of self-inductance for an ideal solenoid. Done? Whenever you're done, just tell me.
Sir, could you please know that? Thank you, sir.
Let's scroll down. So very important thing to note over here, guys. Can you see when we got the expression for the self-inductance of a solenoid? Can you see it is depending only upon certain parameter? Is it depending upon flux and current? Just like Ohm's law, when we discussed Ohm's law, V equals to I into R, R into I. I'll write it like this. So was this R dependent on V and I, guys? Do you remember this R? Was it dependent on V and I? The resistance of the conductor
No.
was dependent only upon four factors: the temperature and the nature of material, which was included in this resistivity, the length of the conductor, and the area, right? So here also the self inductance is independent of, please write note, the coefficient of self inductance is independent of the flux and the current. Okay, it depends only on the number of turns. Can you see it is dependent on the number of turns? L is directly proportional to n square, right? Then second is its geometrical parameters. Geometrical parameters means what? Its area and its length. So can you see over here, L is directly proportional to area divided by length. Yes or no? Can you see this? The third one is basically material inside the solenoid. Material inside the solenoid, can you see over here, L was directly proportional to mu naught, right? Right or wrong? If the space inside the solenoid, just for example, suppose if it is air, then the permeability which you will be used is basically mu naught, right? But if I have a solenoid and I wrap this solenoid on a soft iron core, right? So basically what will happen here, the permittivity will not be only mu naught, it will be mu r times mu r, just like relative permittivity, right? Dielectric constant, we multiplied it, no? Same thing over here, it becomes mu r times r, so it is directly proportional to this permeability as well. Thick permeability. So these are the three parameters. Please remember the third point, in electrical circuits, a coil or a solenoid is termed as an inductor. In electrical circuits, a coil or a solenoid is basically termed as an inductor. Please write it down. Whenever you're done writing down, just tell me to scroll up or down whenever you want. Guys, whenever you're done. Done?
Yes, sir.
Till the end, are you done? What is an inductor? So now you have three things. Initially, you had a resistor, then I introduced a capacitor in electrostatics, and now you have the third element of the circuit, which is basically an inductor. So, resistor, capacitor, and inductor. These three are the main things which govern your whole electromagnetism, and the main electric appliances, you can say, or electric elements of an electric circuit. Anyways, so is this clear, guys? Any doubt till here? Also, we know this particular thing. If phi is basically equals to Li, and by Lenz's law, where I is the instantaneous current, okay? I is the instantaneous current. Okay, that instantaneous. Then, guys, just give me 2 minutes. I'm getting a call. Jana, to cut gaya. When it will come back, we'll pick up. Otherwise, no need. So if phi is equals to Li and I is the instantaneous current, then what was EMF? If you remember, EMF was basically d phi by dt according to this Faraday Lenz's law, right? Yes or no? So I can write phi equals to Li over here, minus of d into L into I by dt. And if you remember, L is a constant. It depends only on the solenoid that will be taken out of the integration. So always remember E is equals to minus of d phi by dt, and it will be equals to minus into L di by dt. Is right. Here guys, see one experiment I'm telling you. Suppose you have a wire, a straight wire, okay? So suppose guys, this was your coil, okay? Or this was your wire, and I have connected a battery across this wire. So basically, this wire will have certain resistance, right? Yes or no, guys? Yes or no? So tell me, if I press this switch at t equals to 0, if I press this switch at t equals to 0, then can anyone tell me what will be the graph for current versus time? Can anyone tell me how will the current rise or fall in the circuit? Obviously, when you are switching on, then what will happen? A current will start flowing, right? But will that
Yes,
current,
sir.
can anyone tell me what exactly will the value of that current be? What will be the value of that current? The current will be E divided by R, right? This will be the maximum value of the current, E divided by R. But can you see how exactly it will rise? Since there is nothing to oppose the current, right? So what will happen? The current will rise very fast, very quick. Can you see the graph? And it will become maximum in a very small interval of time. Very small interval of time, dt tending to 0, right? But what happens? What happens? Suppose the same wire, in spite of just keeping it straight, if I if I do this, or in spite of giving it one turn, let's give it many turns. The same wire only. I'm not changing the length of the wire. It's the same wire. Yes, like this, guys. Tell me what will happen now. What is the difference between this and this? Can anyone tell me what exactly is the difference between the first case and the second case? Am I changing the resistance? The resistance will be the same. The length of the wire is same. The area of cross section is same, right? Yes or no, guys? If the
Yes, sir.
length and area of cross section remains same, the resistance will not change. But by coiling it, what exactly I did? I turned this wire into a solenoid. And when this happens, this solenoid has certain flux associated with it. And now when this current it increases through time, then what happens? This solenoid tries to oppose the increase in the current. So when at t equals to 0, when you press the switch, current doesn't become maximum all of a sudden. It becomes maximum after a certain amount of time. Do you remember this type of graph? It was already drawn earlier as well. Does anyone remember this thing? Do you remember RC circuit?
Yes, sir.
So
So,
basically, this will be the from here to here. Can you see from here to here? This will be called as the transient period of the RL series circuit. So do you remember, guys? Initially there was RC series circuit. Now there is RL series circuit. Again, there will be a charging and discharging thing, but in this case, we don't call it charging and discharging of capacitors. We call it as growth and decay of current. Okay, so we'll be seeing that. Please remember, here in this case, when switch is closed, the current in the circuit, rises sharply. Whereas in this case, what will happen when switch is closed? Then due to self inductance, the growth of current takes place slowly. Clear? Please write it. Have you noted down the things which I discussed till past? Done, guys?
yes, sir.
Chale. So basically, this will be the case. We'll see, how exactly things will work out. But before that, let's see how all these things behave. So the next is basically right on the next heading: behavior of an inductor in electrical circuits. Basically what we are studying is applications of Kirchhoff law. Sir, Kirchhoff यहाँ पे भी? Yes. Sure. So let's start. Suppose guys, this is an inductor. Inductor is basically, I told you, it's nothing but a solenoid. Okay. So suppose if this is an inductor and if this is there is a current which is flowing, I current is flowing through this inductor. Okay. And the first case is basically this current is constant. So tell me, what will this inductor do? If I say this is a, if I say this is an ideal inductor, although which is not technically possible, it's theoretically only possible. So suppose if I have an ideal inductor that implies the resistance is zero, then this thing will not be doing anything. It will just behave as a short circuit wire, right? Yes or no, guys? It will just behave as a closed wire, right? Because there won't be any change in the current. If there won't be any change and it doesn't have any resistance, then it will not behave as a resistance as well as inductor. It will just behave as a wire, right? If it's a real inductor, if it's a real inductor, that implies it has certain resistance as well. The L comma R it has. So can you see L comma R? L comma R means it has certain inductance as well. It has certain resistance as well. You already used this particular thing when we were discussing batteries, right? So a real battery has certain potential difference as well as a certain internal resistance, right? So we wrote it like 12 volt comma 3 ohm, just the same, exactly same. If it is a real inductor and if still the current is constant, then it will behave just simply as a, okay. Is this clear, guys? In the first case, it will behave as a short circuit wire. In the second case, it will behave as a resistor. And this will be only happening when the current is constant. Is the first case clear, guys? The second case, please write it. Then we'll start with the second case. Done. Now the second case, let's say the current is increasing with time. Now the current is something, but now the current is not constant, it is increasing with time. Now when the current will be increasing with time, see now what will happen, guys. Suppose. Achha, guys, you understood this particular thing. If it's a real inductor, so basically what will you do? You'll just place a resistance. Na? So we'll be discussing only ideal inductors, and whenever it will be a real inductor, then you know what to do. You'll just place a resistance in series. So suppose this is your inductor and this is your current. This current is basically increasing with time, right? Yes or no? Hello? Guys, tell if current is flowing in this direction. Yes or no? Hello? Hello, people.
Yes, sir.
If
Yes.
current is, do you remember that when we used Lenz's law, application of Lenz's law, we studied B external, then B induced, if anyone remembers, right? So see, directly we can do it. First of all, tell me this particular thing in a battery. In a battery, the current the current flows from where to where? Outside the battery, it flows from positive to negative, right? And inside it flows from negative to positive. Everyone knows this thing, right? Inside a battery the current flows from negative to positive. Everyone knows this, right?
Yes,
Huh?
sir.
So but this will
Yes,
be the
sir.
key concept of how we will determine it, no? So remember this. So now see over here, this current is increasing. So basically the current is flowing in this direction. I external is flowing in this direction and it is increasing. So what will I induced do? I induced, can you see, to decrease this increase in the external current, what will I induce flow? What will be the direction of I induced?
The opposite way.
The
Opposite direction.
opposite. So basically I induced will be flowing in what direction? I induced, will it be flowing from this direction? Or let me just draw it with a different color so that you will be able to explain this. So I am drawing it with a small I. Is it fine? So can you see I
Yes, sir.
induced is should flow in this direction. If I induce should flow in this direction, then this inductor, which end should be positive and which end should be negative in this inductor? Please remember this. This inductor will start behaving as a battery, but can you see what is the direction of induced current inside this inductor? From negative to positive. That implies this end. This end.
Same.
So if I name this end as A and this end as B, okay, so end A will behave as a
Positive.
positive and end B will behave as a negative. Positive means what? By positive I meant the high potential end, and by negative I meant the low potential end. So always remember, basically whenever you have a inductor given, and if in this inductor there is a current flowing through which the current is increasing with respect to time, then this inductor will behave just as a battery with positive terminal over here, negative terminal over here. So can you see, end A and end B is still over there, and A and end B is still over there, but can you see the positive and the negative terminal? Shall I explain it once more? Guys, shall I explain it once more? Whenever current is there, this current was flowing from right to left. oh sorry, from left to right, and it was increasing. So basically what will this I induced think? Yeah, I don't want this current to increase, I'll reduce it. For reducing it, it should flow in the opposite direction of external current. So it started flowing in the opposite direction, and for I induced to flow in the opposite direction of external current, this end should be negative and this end should be positive, so that then this inductor will be represented as a battery. So can you see the direction of I induced inside? Can you see I induced from inside? Yes or no? Yes or no, guys? So now you understood how we will determine the polarity of this inductor cum battery, right? And what will be the EMF across this battery? The EMF will be E will be equals to L into Di by dt. Can you see no sign? Only magnitude. And this will be here as this. Are you getting my point? Is this clear, guys? This EMF will be equals to L into Di by dt. Please write. And which current, since let me make it capital I. Why am I making it capital I? Because can you see over here this I? How this current was changing, it is basically the EMF is basically dependent on that. Is this clear? So ideal inductor behaves like this. How a real inductor will behave? If suppose if this is a current I which is increasing with respect to time, then if this has L comma R and this end is A, this end is B. So this end A will behave as the positive one and this end B will behave as the negative one, just similar to previous case. But when you will write it like this, just draw. Are you getting my point, guys? What is the only difference between a real conductor, a real inductor, and an ideal inductor?
Yes, sir.
You'll just draw this in series. And please remember here this E will be equals to VA minus. Okay? The positive minus the negative. Shall I make you write the whole thing which we thought over here? Yes, fine. You understood. It's just in accordance with Lenz's law. Whatever you did with B external, now you need to do it with I. Yeah, very done.
Yes, sir.
Chali, can you do the third case now? Can you do the third case where current is now decreasing with time? If current will be decreasing with time, then who will tell me how to do it? Again, the same ideal inductor this is end A, this is end B, and now a current I is flowing from A to B, and this current is now decreasing with time. If it is decreasing with time, then what will happen? Who will be applying a logic over here? Anyone would like to try? See over here, the I external is in this direction. Yes or no? And it is decreasing. If I external decreasing, what will the inductor think? Will the inductor let it decrease, or will the inductor
No.
will say, "No, if you are decreasing, I'll let you decrease."
No, it will try to increase. So
It will try to increase. If it will try to increase, then what will it do? It will try to induce
the
a
same
current
direction.
in the same
Same
direction.
direction.
For the current to be induced in the same direction, what shall be A? Shall A be negative or shall B be negative?
A is negative.
So A will become negative over here and B will become positive over here. So basically here EMF will be equals to L into di by dt, but here it will not be VA minus CB, it will be VP minus VA. VP will be greater than. So when this will behave as a battery, current will be flowing in this direction, and this will behave like this. Did you guys understand the concept?
Yes, sir.
If someone has a problem in this concept, I have another convention as well. Okay, but before understanding another convention, we'll do some questions on this concept so that at least a little bit idea should be there. Okay. Done.
Yes, sir.
So, acha, what will happen if this will be a real inductor? You'll just add a resistance in series with this. So, question. I'm giving question. All the concepts of Kirchhoff law will be applicable over here. Na? Don't think like, sir, we are done with current electricity, but still we are dealing with Kirchhoff again. This is X, this is Y, this is 0.5 Henry, this is 15 volt, and a current of I is flowing from X to Y, and this I is equals to 5 ampere. Okay. Okay, guys, a current is flowing from X to Y, and when at t equals to 0, the current is basically 5 ampere over here. Okay. Now, the question is, this circuit section XY shown in the figure carries a current 5 ampere. The current I, which is equals to 5 ampere, is decreasing at a rate of 10 ampere per second. Then find Py minus Vx. This is the question, guys. Let me see what logic do you apply in this. Done? Yes, can anyone tell me what's the answer? See, I'll tell you how to do it. Then next question you people will do. Okay? देख सबसे पहले this current was flowing from x to y, so basically in this solenoid the current is flowing in this direction, right? Yes or no, guys?
Yes, sir.
The external current is flowing in this direction, and this external current is decreasing. It is given in the question. Can you see?
Mm.
So if it was decreasing, so what will be the direction of I induced? I induced will be acting in the same direction. If I induced will be acting in the same direction, that implies this end will be positive
Negative.
or negative. Hello. This will be
The
negative.
first end is negative.
If this will be negative and this will be positive. After this, what will you do? You will redraw the circuit again. This will become X. This will become 1 ohm. The same current, resistance will not change. The battery will not change. What will change? Only what will change? This will become a battery again with negative over here and positive over here. Yes or no? Yes or no? So can you see what is the only change over here? This becomes this. And what will be the EMF of this battery? It will be L. And what is the di by dt? Can you see this is basically how the current is changing with respect to time? So basically this is your di by dt. This will be multiplied by 10. Can you see I'm not writing a minus sign over here because direction I thought and magnitude I am writing, right? So 0.5 into 10 and this will be 5. So basically this battery will be 5 volt. And now anyone can go from we wanted to find out what is Vy minus Vx. So let's start applying open circuit Kirchhoff. Vy, now you are entering from batteries positive terminal to plus ki minus. Batteries positive terminal plus ki minus.
Minus.
Minus 5. Then again batteries plus positive terminal plus ki minus. Minus
Minus.
15.
Minus.
And what was the current? Now can you see we are going against the direction of current. So plus current multiplied by resistance. Resistance is 1 and current was 5 ampere. And this will be equal to V. So can you see from here Vy minus 20 plus 5 is Vx. And from here Vy minus Vx is how much?
15.
The answer. Are you getting my point, guys? Shall I give you one more question just
Yes.
like this? Then I'll give you a typical one as well. Do it now. Two ohm, 10 volt, 3 ohm, 3 Henry. Okay. And they have given di by dt as minus of 0.1 ampere per second. What do you mean by this minus sign?
Decreasing current.
Decreasing. So di by dt, if it is negative, that implies it is decreasing with time. Please remember, whenever someone says current is decreasing with time, that implies the rate of change of current should be negative. So please write it over here itself. When we discuss all three cases, write it over here only. Di by dt, here di by dt will be positive. And here if it is constant, then di by dt will be 0. Okay. So now this is the case and they are asking you find dA minus dB. There should be current as well. The current is 2 ampere. It's a very similar question based on the previous question. Please do it. Done. Done. बहुत लेट करते हो यार तुम लोग, जल्दी करो. So basically again it's the same case. Can you see the current is going from A to B? The current is going from A to B and it is decreasing. Then in the same way, I induced will be acting in the same direction, and hence this will be a negative and this will be a positive. And basically what will be the case? This will be exact same, and when this will come, it will behave as a like this. Okay. Okay, guys. And I'm not doing after this.
Yes.
This will be 3 multiplied by 0.1, negative, positive, negative, positive. A 2 ohm, 2 ampere, 10. And now you people can solve. You know how to apply open circuit Kirchhoff. The answer would be VA minus VB would be minus of 0.3. This will be the answer, right? Now there
Yes.
is one more way. If people are getting confused, sir, I don't know how to apply this Lenz law and get the direction of this thing, then still it is simple. Okay. Do you remember when we were another trick? I'll give you another. No need to convert to battery and all. Just remember it like this. And when do you remember in Kirchhoff when we used to move in the direction of current? Was it negative or was it positive? Hello? When we were through a resistor, when we were moving in the direction of current, then delta V was positive or negative? Hello? Was it negative, positive? सब भूल गए हो?
So it was negative.
It was
Negative.
negative, right? So basically when we move in the direction of current, so what will you do? You will do delta V is basically L di by dt, तो लिखना ही लिखना है. Just write a negative sign. And the second case will be when we move in the direction opposite to current, then if we are moving in the direction opposite to current, then delta V will be positive or negative? Or a positive or negative? In this case delta V will be negative, and in this case delta V will be positive, just like Kirchhoff's law. But the only twist is, if once you have decided this, then put di by dt with sign. What do you mean by put di by dt with sign? If current is increasing with time, then di by dt will be positive. And similarly, if current is decreasing with time, then di by dt will be. So we'll do the same thing. Control C, Control V. So can anyone apply Kirchhoff's law? Open circuit Kirchhoff. No need to apply this thing. No need to convert it to a battery. No need for this positive negative sign. Nothing. Don't apply Lenz's law. Just directly write. Can you see? Let's move. We were about to find VA minus VB, right? So let's start from VA. So VA. Now we are going in the direction of current, plus minus. We are going in the direction of current, plus or minus? Minus current multiplied by resistance, so 2 into 2. Then we are going from the negative terminal of the battery, hence plus 10. Then can you see we are going in the direction of current? Are we going in the direction of current? Yes or no, guys?
Yes, sir.
So minus L into di by dt. Di by dt, can you see it is negative? So please put this negative sign. Are you getting my point now, guys? And then last one, what was the current again? 2 ampere was the current. So hence minus 3 into is equals to 3. So when you solve this, can you see this will be minus 6, this will be minus 4, minus 4, minus 6, plus 10. Cancelled out with each other. VA minus, oh sorry, minus into minus will become plus, plus 0.3 is equals to VB. And can you see again, VA minus VB is minus of. And that was the answer, if you remember. Yes or no, guys? Is this clear?
Yes, sir.
Thank you. So I think you people are well aware in this thing now, है ना? How to use Kirchhoff's law, 2 different tricks, है ना? Yes or no? Shall we start the RL series circuit part, just like RC series circuit? Shall we start the RL series circuit part? So RL series. First part basically which we are doing is called as growth. The growth of current. Growth of current is just similar to charging, okay? Growth of current in an inductor across a battery. Suppose if this inductor is let's say ideal. The first case which I am doing is ideal inductor. Then see what happens. You have an ideal inductor over here. It will only have inductance. It will not have resistance, right? Plus E, and this is the switch which will be closed at t equals to 0. So suppose guys, there is this thing. There is a inductor, a pure inductor. Can you see there is no resistance over here? If there would have been any resistor, I would have written over here. So let us consider a pure inductor, and this pure inductor, let's say if I close the switch at t equals to 0. We close the switch. What will happen when we close the switch? Current will start flowing, right? Are yes or no?
Yes, sir.
So let's say a current will start flowing. Will this current be increasing or decreasing in nature? Since the current will be growing, when you have closed it, the current will be growing, right? So this current, will it be increasing in nature? If this current will be increasing, then what will happen to this inductor? What will it do? Can anyone tell me what will this inductor try to do if the current is increasing?
Try to decrease the increasing current.
So try to decrease. How will I decrease it? Which will be positive? Which will be negative? Will I try to decrease it like this?
The one towards the left will be positive. Yeah.
The induced direction should be like this. So that's why this should be positive and this should be negative, right? Yes or no? So at t equals to 0, we close the switch. The inductor tries to oppose the growth in current. Growth is basically increase in current, right? By setting up an EMF in the opposite direction. Yes or no? But can you see, guys, this particular thing? This point is directly connected to this point, and this point is directly connected to this point. So can you see over here the potential difference in this case? The EMF setup in this case, will it be equals to the EMF of the battery? I'll write the statement. In this case, the EMF produced by the inductor will be equal to EMF of the battery. Yes or no, guys? Will it be equals to the EMF across the battery? Can you see over here the positive end is connected with the positive, the negative end is connected with the negative. So whatever is the potential difference across this battery, that will be the potential difference across the inductor, right? Yes or no? So here in this case, E will be equals to capital E, right? Yes or no? Are hi na? And can you see this was basically equals to di by dt, L into di by dt, right? So can you see over here? I can write di is equals to E by L into dt. I can just integrate it. When the time was 0, the current was 0. And the time became t, the current became, let's say, I. So if I integrate this di and dt, will I get I is equals to E by L into T. Will this be the current? Yes or no? Yes or no,
Yes,
guys?
sir.
So can you see over here, when current was 0, or when time was 0, current was 0, when time became T, the current became I. So can you see over here, I, E by L into T. These two things are positive always. Time is also positive. Time always increases, right? So can you see this thing? If I draw a graph of this particular thing, this particular current with time, will it be a straight line? And that straight line will pass through origin. Yes or no? Array, yes sir. So in this case, if I draw a current versus time graph, this is put on y-axis, this is on x-axis, y equals to mx, straight line. The slope of this line will be equals to E divided by L. But can you see it is positive? So the current keeps on growing with time. So if you have an ideal inductor, that implies the current will keep on rising till infinity if you keep it switched on for a long time, right? Yes or no? Can I say this thing? The current can rise linearly till infinity. Yes or no? So can you see the current can rise linearly till infinity? But is this actually possible? No. This is a hypothetical case. Please remember. It's a hypothetical case. It doesn't exist. As ideal inductor is not possible. So basically, by introducing this thing, by introducing a current, by introducing a resistor, what exactly do you do? The thing which keeps on going till infinity, it gives a definite value, and we'll see exactly what is that definite value. Okay. Please remember, if this angle is theta, then tan theta will be equals to E by L. Slope, है ना? Always remember the slope has formula tan theta. Clear? Guys, for the next chapter, I'll be giving you notes. I have already some notes of mine. They are in the printed form. They're not. So I will not be giving you notes for the next chapter, magnetism and matter, like this on notebook. One note, one note. Okay. So those notes will not be handwritten. They will be printed. Basically, they will be in PDF soft copy form. So when you'll be back, I'll just mail it to you, or I'll give the printout from the center. Let's see. Whatever is the case, we'll discuss. So anyways, is this done? So guys, give me 2 minutes. I'll be back. Sorry, please write down the next heading. Growth. No, we already gave this heading, right? We already gave this heading, right? Now, second case, real inductor. If it's a real inductor or it's a RL series circuit. Please remember, if it's a real inductor or a RL series circuit, it will look like this. It will either look like this. They will just draw a inductor like this. They will just draw a solenoid like this, and they will connect it to a battery, and there will be a switch, plus minus E, the switch S, and they'll just write L comma R, either like this. Whenever there is a resistance in this particular inductor, what will you do? You will always do what? You will always separate them. You'll make this as an ideal inductor, and then you have a resistor over here, right? So this is nothing but a LR circuit, LR series circuit, or RL series circuit, right? Yes or no, guys? So shall we start? Shall we start? Now see, guys,
Yes, sir.
when you will press the switch in both the cases, what will happen? When we will press the switch at t equals to 0, when you will press the switch at t equals to 0, a current will flow in the circuit. Let's say the current is how much? I. एक second, let me close the gate. महिमा, मैं गेट बंद कर दे यार, आवाज आ रही. So I is this. So this current will be increasing, right? Hello people, will this current be increasing? अरे बोलो. Yes or no? So this current will be increasing. If this current will be increasing, so what will happen? This inductor will try to oppose it, right? So this is current is increasing. So now, let's say at t equals to 0, at t equals to 0, initial state. Okay, at t equals to 0, what was the current in the circuit? The current in the circuit was 0, right? But the rate of increase of current was maximum, right? Because initially, since there is no current flowing, then the rate will be maximum. The current will try to become maximum in one instant, right? If there was no resistance present over here, if there is no current flowing in the resistance in the circuit, then there is no role of this resistor, right? If current is 0, then there is no role of this resistor. It will behave as a pure inductor, and at this particular instant the current will try to become maximum in an instant. So at this instant, the current in the circuit, the rate of current in the circuit will be maximum, not infinite. It will be maximum. Okay, what will be this maximum rate? We'll see later on. Now what will happen at any general, अरे भाई निकल जा. This is sometimes it becomes a problem in India. People are like this one. Okay. So at t equals to t, just give me 2 minutes. At t equals to t, that implies at any general time t, right? This is the general condition. General condition, or basically general time t. This is called a transient state. At any time in between, the current, let's say the current is I, and the rate of change of current is di by dt, right? So at any instant they are like this. What will happen at steady state? Guys, tell me what will happen at steady state. At t tending to infinite, after a very very long time, steady state will be occurring, and everyone knows steady state. In steady state, the current here in this case, the current will become constant, and here the di by dt will be. Are you getting my point, guys?
Yes, sir.
Yes, sir.
Basically this thing will be happening over here. So we are going to study this di by dt state, okay? Or shall I do it state wise, this thing? Chalo, steady state पे transient state पे कर लेते हैं. So at the transient state at any general time t, please remember, abhi jo bhi pad rahe hain, it is not a part of your school syllabus, but still people ask questions from this. School maybe you may find some questions which are based on RLC circuit, although generally they will not ask. The current is I, and here the EMF in this thing is L into di by dt. Tell me, if the current is increasing in nature, then this will behave as the positive end, and this will behave as a negative end. Yes? एक बार check कर लो if my signs are correct or not. The current was flowing from right to left, it was increasing, so hence induced current was flowing in the opposite direction. So can you see that is why this is negative and this is positive? Okay? So ये already sign मैंने बना दिया. Now this will be behaving as a battery like this. If this will be behaving as a battery like this, then can anyone write EMF? Can anyone write KVL equation for this loop by Kirchhoff's voltage law? Let's start from here. Then when we go from here to here, the current is I, the resistance is R. We are going in the direction of current, hence minus I into R. Then we are going in the direction of current. Guys, we are going in the direction of current. So hence, just tell me this. We are going in through the positive terminal of this
Negative.
battery. So minus of L into di by dt. Yes or no?
Mm.
And then when we come back, this battery has positive terminal, so plus E should be equals to 0. So by Kirchhoff's
0.
voltage loop, is this the Kirchhoff's equation? Yes or no?
Yes, sir.
So can I solve it and make it like this? V is equals to L into di by dt, and let me make it as E minus I into R. So E minus IR, can you see I have just transferred this to the right hand side. E minus IR is basically this. From this equation I can write di divided by E minus IR is equals to dt divided by, can I write it like this? You see, dt I shifted over there, L I shifted in the denominator, and E minus IR shifted in the denominator of dx. And then I'll do what?
Integrate.
Now when the time was 0, the current was 0. You remember the initial state? Can you see? When the time was 0, the current was 0. So when the time became t, the current became I. So from here I can solve, I guess. Now, what is the integration of this? Can you see it is of the form ax plus b? We know integration of dx ax plus b is ln of ax plus b divided by whatever is the coefficient of x, that plus c, right? Everyone knows this thing. I think integration सबको याद है. So this, in this case, this will be acting as E will be acting as your what? This E will be acting as your B, and this minus R will be acting as your A. Then only it will be of the form AX plus B, right? Can you see the variable is I here? So when you integrate it, this will become ln of minus IR plus I divided by minus I. Can you see now AX plus B format, right? Can you see AX plus B format, right?
Yes, sir.
Minus R ln, and now we need to put the limits from where to where? From 0 to I. This will be equals to, when I'll put limits from 0 to t over here, this will become t by L, right? Yes or no? This will become t by L, right? So can you see, I can just send this minus R over there. So when I send this minus R over there, it will become minus of R by L into t. This will become ln of E minus IR. When I'll write I over here, so it will become ln of E minus IR minus ln of, when I'll put I की place to 0, then it will become ln. When I'll solve the limits, it will become something like this, and this will be ln of E minus IR divided by. Yes sir. So right now I'm just solving a little bit, mathematical part only. Now when I'll send this ln over there, it will become E to the power minus R by L into t, and this E minus IR will become 1 minus IR upon E, right? Yes or no? Yes or no, guys?
Yes, sir.
After this, I need to get an expression of I. So I'll just do one thing. I'll go, I'll shift this on the right hand side, shift this on the left hand side, and then E and R.
Where did ln e come?
Where did
Just minus ln e.
when you solve the lower limit, when in place of small I you wrote 0. So can you see, when you wrote 0 over here, this term became 0, but E was still there.
Okay.
So ln of E, that EMF thing. Okay.
Okay, sir.
So ultimately, this will become something like this. So 1 minus IR by E is basically this, and on final solving, this will become I is equals to E by R into 1 minus E to the power minus L R by L into. Do you remember, this thing is somewhat similar?
Similar. Yes, sir.
This thing is basically the maximum possible current. So here this will be I naught and 1 minus E by R by L into T. Sir, how is this similar, sir? Do you remember if I draw oh sorry. If everyone remembers this, if it was a RC circuit. RC. Then the charge over here was what basically? Charge was Q naught into 1 minus E to the power minus, yes, P by RC. Everyone remembers this? Does anyone remember this formula for RC circuit? Charge, right? Similarly, when it is R L circuit, then here current will be equals to I naught into 1 minus e to the power minus R by L into T. So can you see what is changing only RC, this term which is in multiplication with time, the term which is in multiplication with time, RC, and here it becomes R by L. So only that is different. Rest everything is same, right? Yes or no, guys? So please note it down. Note it down. In the next class, we'll continue from this transient state onwards, the graphs and all. Done, guys. Shall I scroll up or down? How many people are absent today? Satwik is not here. Shrish is not here. Is Abel here? Yes, Abel is here. Mithil. Vaidehi is not here. Navina, Krishna, Vaishnavi. Ovya is here. Darshana. Arya? Where is Arya? Arya is also here. 13 के पास 14, 16. There's one more. Chalo, anyways, we'll send you this thing. Chalo, guys, thank you very much. I hope